this particular lecture, we're going to look at matrices and vectors in PETSc. And if time permitting, we're going to solve a simple algebraic equation and see all the objects that we can access. So in the previous class, we looked at some aspects of MPI, but in this particular lecture, we're going to make use of a single processor just to avoid any kind of confusion. So let us try to create this particular vector 7 1 2 4. So it's a 4 cross 1 vector, 4 rows and 1 column, and yeah, so all the elements are non-zero, as you can see. So let us see how we can go about defining this particular vector. So as usual, we'll create a new file, and first things first, we're gonna import PETSc. So hash include petsc.h. Then we're gonna make the main function. So int main arg, so int arg c char star star arg v, and we're gonna return the output of PETSc finalize. And we've looked at PETSc finalize. So PETSc finalize is like wrapping up the code, and the return value is simply the IERR, that is the error signal. So it's going to be an integer, so we can return that. That is the conclusion of the code. So there are certain things that every PETSc code must have, right? So first things first, there has to be a PETSc initialize. If there is a finalize, there has to be an initialize as well, and the initialize takes the command line arguments and some help string. All right, so with this out of the way, so we have PETSc initialize and this. So now we must declare certain variables. So in order to declare an array, the way to do it is to tell which elements are going to be non-zero, right? So what we can do is, so let us declare some some variables that we will need. So we will need a vector, let's call it b. So vec is a data type inside PETSc, and so it is a vector, right? So similar to this, there is a data type called mat, but we'll come to that later. So b is a vector. All right, so we will need the integers where we're gonna insert values, and of course we're gonna need some we're gonna need an array of numbers with which we're gonna fill in the array b. Okay, so I mean, this is a very synthetic example, and over here you're not going to truly appreciate the power of PETSc, but I'm going to give you some pointers on how this may work out. Not may work out, it works out. So we're going to create a double array, we're going to call it AB, just to distinguish it from B. And the A prefix, I use it so that it reminds me that it is like an auxiliary array to B. Okay, so let me declare this as, so what did we have? 7124. So 7.0, 1.0, 2.0, and 4.0. So this is the elements that we want to put inside B. And apart from this, what else are we going to need? Anyway, so as we go ahead, we're gonna declare things as and when they come. Okay. So the way to initialize or create a vector is the following. So first things first, you must do vec create. You must then do vec set sizes. So this is a common procedure of declaring a vector. Then we must do vec set from sizes, from options. Then we must, so over here we must set values. Okay, let me save this file. Alright, so now we have some colors. So there must be some code over here which will sort of assign values into this. Then what do we have? We must then assemble the vector. So vec assembly begin, and then we must follow this particular function call by vec assembly end. And it's just a idiosyncrasy of this particular library. You have to do this always. These two follow each other. So I have not yet put in the arguments of this function calls, but the argument of assembly end is going to be the vector that you're going to populate, and B is also going to be this. So yeah, so far so good. So now vec create. So vec create must be done over. So since we are using one processor, well, it's not just a question of one processor, it's a question of making the address of B available to all the threads that you will declare. That's why you have PETSc com world and you are giving the address of B. Now inside set size, you must tell that we must set the size for B, and we must let PETSc decide. I'll come to the syntax in a while. And the size is going to be 4. Alright. So PETSc decide, this particular keyword is used to signify the fact that if you're using multiple processors, so one processor will maybe initialize these two, one processor will initialize these two, things like this. I mean, so for such a small array, it doesn't matter, right? But once it starts becoming very big, you may benefit tremendously by distributing the load over several processors. All right. So now once we have set the size of B, so this is the overall size, and PETSc decide will decide how to distribute the load. All right. So now set from options, it has to be only passed to B. Now we must set values. So there are various ways of setting values. So let us start with method 1. I mean, rather than going with method 1, I'm going to show you the easiest method, which is vec set values. And vec set values must first accept the argument B, that is the vector you want to populate. Then how many entries do you want to populate? That is 4. Then we must specify the indices where you want to populate. So okay, so we must create an integer array. So let me call it J, and we'll make this J4, and we will make it 0, 1, 2, 3. Right. So J is the address of the array which holds the indices where we want to insert these non-zero entries. And I'll change this and show you how it will affect the code. So we want to insert 4 values at the J locations. So J is the indices where you want to insert, and lastly we want to tell what exactly we want to insert. So we want to insert the entries inside the array AB. So AB is the address of the array 7124. Okay, and how do you want to set the values? There are two modes. one is insert values, and one is add values. So if there is an already existing entry for B, if you do add values, you will sort of add whatever you're doing to the existing values. If you do insert values, it will erase the value and insert the present values. All right, so far so good. So yeah, this assembles the matrix, and in the end, before finalizing, we must do vec destroy. We must clear the variables, so we must give the address of B, and that's it. So let us save this. Let us go to our make file and create a new target. So let me hit Control H. Oops, Control H, and I want to replace this by declare vector. Okay, so replace. So there's no use of like rewriting this entire thing. We're simply having the same variables and rules. We're just making a new target, right? So let's save this file. So we have our code over here. All right. So make DCL vector. Okay, there appears to be an error. So let us see what the error is. So there appears to be so this has to be set sizes. Oops, yeah. Okay, so it compiles nice and well. So let's just do dot slash declare vector. We have to allow this. Okay. So it does nothing as expected because we have not printed anything. We have not like asked it to do anything for us. But what we can do is pass this command line argument minus vec view, and it will show us the elements of the vector. Okay. So additionally, we can insert this vec view inside the code itself. So what we can do is vec. So before destroying the vector, we can do vec view. We will pass b, then PETSc viewer std out world, just to say that it has to run on a single processor. So let's make it again. Let's run it, and now it shows without having to pass the extra argument, so without using this. Okay, all right, so we have now initialized this. Now, so what happens if we still make j equal to this, but we only do b as, so we only want to insert 3 values. So we still have the 4 indices and the 4 values, but instead we say we want to insert only 3 first indices at the first 3 indices, the first 3 values. Let's see what happens. So look, it's initialized it to 0 instead of getting a 4 because we've not told it to populate b with 4 values. We've only told it to populate with 3 values. Similarly, if I do only 1, it will only populate the first value. Let's make it again. There you go. Okay, so it's incredibly versatile. You can declare everything you want, but in the end, if you want to fill partially, you can choose to do that. There's nothing wrong in that. So this is how we can declare vectors and sort of print them out. Well, there are various ways of viewing a vector as well. So like I told, I'm gonna show you the function reference. So vec create. So it requires the MPI communicator, which in this case is PETSc world, and it requires the pointer to B, the address of B. So we have passed the address of b, ampersand b. That's standard C syntax. So vec set sizes. So it sets the local sizes. So we have to pass the vector. The small n is the local size. If you have multiple processors, then you have to pass small n. But in this case, we have let PETSc decide, and then the global size. All right. So the global size of our array is 4, but we have asked PETSc to decide for us the best load balancing it can do. In this case, we are running it on one processor, so it doesn't matter anyway. All right. So with these options, it's gonna initialize b over here. So now vec set values. Let me go to the function reference. Vec set values. All right. So it requires the vector, the number of elements to add. Look, it's the number of elements to add. In this case, we wanted 4, and I've showed you what happens when you reduce it. If you increase it, it will. Let's see what happens when we increase it. Okay. Before that, we must tell what the indices of insertion are. Okay, and we must tell what values you want to insert, and you can either insert values or add values. So it's quite simple. This is the standard syntax of creating a vector in PETSc. So now let's increase this and see what happens. Let me make it 6 just to go beyond the boundary case. So let me make this. Obviously there's not going to be an error over here because we've not done any illegal sentence. And there's an error, argument out of range. So it cannot do that. It gives a big garbage value. So we must have this maximum 4. So let me fix it. Great. So now we will proceed to figure out how we can declare matrices in this particular way. But before we go to that, let's just go to vec view because I want to show you function reference for vec view. There are various kinds of viewers. So there's ASCII, binary, draw. Okay, so there are various kinds of viewers that we have. So there is a PETSc viewer default, PETSc viewer ASCII MATLAB. Let's see what happens when we do that. It will show us the output in MATLAB format. Oh, there's a spelling mistake. ASCII. Alright. Well, there's an error, and it does have to do something with the viewer. Well, for some reason it doesn't work on my PC, but maybe it does on your. Okay. So let us see whether this should work. There's no reason for this not to work. Let's see. Oh, there's some errors. That's weird. Okay. Well, anyway. Okay. So I need to call this function. Anyway, so forget about this. Don't worry about this as a beginner course. We'll just keep it std out world, and yeah. So don't worry about that. We can push a format and then we can print it, but you don't need to worry about all that. So far we have this. Great. So now let us proceed to create a matrix. Alright, so in fact let us modify this file itself. So Yeah, similar to this, there will be a sequence which will follow exactly this vector creation sequence. So there will be a mat create, then there will be a mat set sizes, then there will be a mat set from options, then we will have mat setup. It's to, and this is different from the vector, but you need to set up the matrix. Then there has to be insertion of values. And lastly, there has to be an assembly, and so for that there will be two steps. So mat assembly begin followed by mat assembly end. So unlike the vector, the assembly has to have a certain keyword additional. But first, let us declare the matrix. So mat A. All right. So we've declared a matrix A, and let us create the matrix A. So A will also be 4 cross 4, suppose. So in order to create, once again we have to pass this and the address of A. That's common. Set sizes again. So for vector you need to only declare one dimension, but for matrices you need to declare two dimensions. So A PETSc decide comma PETSc decide, because we have two dimensions and the processor load has to be balanced in two directions, and the size of the matrix. That's pretty straightforward. Set from options, it's simply gonna have the variable A. After this we're gonna set up A. Now we have to insert values. Well, there are again various ways of inserting values, but the most common is the compressed storage row format, the CSR format, compressed sparse row format. Okay, let us. So in the standard CSR format, you're gonna create a MPI AIJ matrix. So what it does is it's gonna store what non-zero entries you have, right, in a single row. It's gonna store the column number and the corresponding value. So this is what it is. All right. So far we have not decided what the matrix should be. So first we have to decide what the matrix has to be. Well, let us create something 1 0 4 2 2 6 1 5 0 1 -1 -2 and 4 3 -2 1. I'm hoping the determinant isn't 0, because later we may be tempted to solve. So if this is A, if this is B, we may be tempted to solve AX equal to B. Anyway, let's declare the matrix B like this. So let me, yeah, okay. So now what we can do is create a double matrix. So A, and the size will be 4 cross 4, and we can actually declare the entire array over here as well. So what is this going to be? 1 0 4 2. Then we have what do we do? 6 1 5 comma then 0 1. Well, we're doing it the hard way because it's so small. We can do it non-programmatically. Later on, you will find tremendous benefit in doing it programmatically. Meaning, you run everything in a loop. There is a distinct logic behind how these matrices will be set up. But in this case, no such thing exists. So we've doubled. So we've defined the double array, and yeah. So we need an integer to loop over 1 to 4. Okay, so we have an integer over here. So what we can do over here in order to do this, so for I equal to 0, I less than 4, I plus plus, now we can insert the elements into the matrix. So the way to do it is mat set values into A. So we're doing it row by row. The fact that I'm using a loop I is to loop over 1 2, so rather 0 1 2 3. So I'm looping over 0 1 2 3 through this particular for loop, and in doing so I'm gonna insert these particular values into this. So since we're doing it in a dense form, we're not really bothering about this 0 over here. It's a dense matrix. So we're gonna do j equal to 0 1 0 1 2 3, which it already is. So it already is 0 1 2 3. So we're gonna take each row of this double array, a double pointer. So we're gonna take each row, insert it as column 0 1 2 3. Then take the first row, insert 0 1 2 3. Second row, insert 0 1 2 3. Third row, insert 0 1 2 3. So once I write it, it will be clear what I mean. So I'm gonna insert one row. I'm gonna pass the address of the row index that I want to insert. So ampersand I means the address of the current row index. Then I want to insert 4 values. I want to insert values into 0 1 2 3. So j is already an address. So j. So the thing is, because I is an integer, ampersand I is the address. But because j is an array, rather j4 is an array, j is the address. You don't need to pass an ampersand for the array. Alright. So these are some things which you pick up in C programming. And lastly, we must pass the address of these fellows, this row, then this row, then this row, then this row, one by one. And so it's a and it's simply gonna be I, and all is implied over here. So in Python you would have done this, but not over here. That is implied. So the address AAI holds these 4 elements. So it's a double pointer. So the two square brackets, the two sets of square brackets means there's a set of pointers which holds another set of which holds pointers to these rows. Okay, so meaning there's a pointer which holds these arrays, and what holds this array? It's AA1, rather AA0. What holds this? AA1, and so on. So we're passing the address of those rows. Okay, so this is how. So lastly, we must tell insert values. Right. So yeah, that's pretty much it. With the help of this loop, after so we've sort of set up what to insert and where to insert. So now we must begin the matrix assembly. So it's a comma mat final assembly, and we have to end also a mat final assembly. Right. So now you must be wondering why final assembly, because there can be a submatrix assembly as well. So you mm, so it can be either flush assembly or final assembly. Okay, but in this particular examples we just need to bother with final assembly. All right, so you can have a look at the function reference, go figure it out. You can try various things, but yeah, this is the general syntax for assembling a matrix. So once we've done this, we must keep in mind that we must also destroy eventually the pointer. So the memory has to be cleared. So we will simply pass the address of A, and we can put a viewer over here as well. So mat view A, and we can use simply the std out, that is the terminal for visualizing the matrix. Okay, there appears to be an there is, it's not vec destroy, but rather it has to be mat destroy. There's a data type error. Okay, let's make it. Okay, there's an error. Let's see what the error is. Have I missed a semicolon somewhere? We missed a semicolon over here. Okay, it's unforgiving in that sense, but yeah, it's incredibly flexible. Okay, so there you go. So in row 0, the first row contains 1. So it's CSR format. So in row 0, 0th column has 1, first column has 0, second column has 4, third column has 2. So the indexing obviously starts with 0. And similarly, you have all the other values. So you can verify this. Now, what we can do is we can print it over here as well. So you can comment out these lines and print out by passing the command line argument. So let's save this, let's recompile, and let's call it with this. So you can simply print the mat view. You can print it as ASCII MATLAB. So this is the MATLAB way of writing it. Okay. So MATLAB indexing starts from 1. 1 comma 1 is value 1. So let's see, 1 comma 1 value is 1. 1042, 2615, and so on. So this is how MATLAB would represent it. There's also a way of visualizing this entire thing. So let me go to the function reference for mat view. Okay, so what do we have? So PETSc viewer draw world. Okay, but we can do this mat view draw. So what we can do is mat view draw. Oh, it quickly came and went away, so we must have a draw pause as well. So look, there's a draw pause as well, which we need to do. So draw pause of 5 seconds. Yeah, so this is how it looks. So the 0 is cyan, positive values are red, the negative values are blue. I'll do it again in case you want to see. Great. So we've seen how to create a vector, how to create a matrix, how to assemble it. There are many ways of doing it, and in the coming lectures you will see some other ways of doing it as well. In general, you will see a programmatic way of doing it. One last thing I want to point out, the graphics that you just saw, For that, you need to install some kind of X11 forwarder. So because we are using sort of a virtualization of Linux, you need to install something like xming or something, whatever you like. You have to open it up. So xming, I have it installed. So you have to open this, then launch the, or you can launch Ubuntu, then launch xming. And how to test whether xming is installed, you just say xize and you will have this funny X11 application in Linux. If this works, everything is fine. If this doesn't work, then you will not be able to visualize things natively from this. But for those of you who are working natively in Linux, all these things won't matter. And I'm too lazy to install the whole thing. The PETSc library is natively in Windows, so that is why I went for virtualization. Anyway, so I hope you will find whatever I've shown useful, and practice makes you perfect. So just go ahead and do various kinds of matrices that you like. In the next class, we'll see how to make a simple solver, and we'll proceed with a 1D problem. With this, I'll see you next time. Until then.